Hi everyone. Today we're going to be focusing on a concept called percent yield and theoretical yield, and how we can predict how much of a product we're going to make based on the stoichiometry. So as a result of this lesson, you will be able to calculate the theoretical yield for a reaction. This will be using stoichiometry. And you will also compare what you actually make. So this is from a lab setting, what you actually make, and compare the two of them. So did you make what you were supposed to make? Did you make less than you were supposed to make? That's how we would determine that. So the formula to calculate percent yield is taking the actual yield, like what you actually make, divided by the theoretical yield. So the actual yield will come from lab data, and the theoretical yield will come from stoichiometry, okay? So we've kind of looked at that previously with our sodium bicarbonate lab because we knew how much we were supposed to make, then we compare it to how much we actually make. So to define these, to make it a little bit easier, a theoretical yield is the maximum amount of product that I could potentially make based on a reactant. So sometimes I like to write this as like, in theory, use that word theory, I could produce this much. The actual yield in comparison then is what you actually make. So sometimes things go wrong in chemistry. So in lab, I actually produced this much. So I kind of like to rewrite it like that. So you're comparing the two between your theoretical yield and your actual yield. You want these to be as close as possible, but sometimes things go wrong. So what could potentially happen? If you have a reaction that is not as efficient as it needs to be, meaning your actual yield is less than the theoretical yield, something happened somewhere along the way. Your actual yield is what you actually make. So if something goes wrong, like in this example here, we have a little mouse steal some of the food and oh no, now we can't make as many sandwiches. This can happen in the lab if we have a reaction not go to completion. So for example, with our sodium bicarb lab, not heating it long enough. So sometimes if we don't let the reaction go all the way through, it's not going to fully react and we're not going to make as much product. Sometimes the reactants never contact one another. So that's why sometimes we will stir them to kind of force them to come in contact with each other. We might have some side reactions that are happening, so that can sometimes occur as well. And we might just lose some product by adhering to containers, filter paper, other equipment. So there are some things that can go wrong that will potentially impact our percent yield. This is going to be really important when we look at chemistry applications like manufacturing. If I am a drug manufacturer, and I give my employees X amount of reactants, and I tell them I need to have exactly this many pills when you are finished. If you're making less than what I'm expecting you to make, your productivity is down, you're not being as efficient, and you could potentially get fired. So this is a really useful problem for solving some of these things. So how we would actually use this in an actual problem. So I'm not going to write anything necessarily down for solving it here. We're just going to look through this and kind of break it down. So when potassium chromate is added to a solution containing 0.500 grams of silver nitrate, solid silver chromate is formed in the reaction. So we can see here that solid silver chromate is right there. So determine the theoretical yield. So we're theoretically determining how much silver chromate we would make. So what that means is I need to figure out the grams of Ag2CrO4, but I don't have any information about silver chromate. All I have information about is that I have 0.500 grams of AgNO3. So I got to figure out some way to convert grams of silver nitrate to grams of silver chromate. This is stoichiometry, okay? So using theoretical yield, we're going to do the stoichiometry for it. So first off, we're going to try to determine what kind of chemical reaction is shown here. So if you see, we have, oops, that was a pen. I wanted it to be a highlighter. We have a metal here and a metal here. The nonmetals I'm highlighting in green. And if we notice, as a result of this reaction, I think I accidentally muted myself, sorry. But in this reaction, we have our metals in blue, our nonmetals in green, and what is happening to them? So we have them switching partners. What kind of reaction would happen where they're switching partners? That's a double replacement reaction. So then how do we actually go through and solve the stoichiometry for this? So we're going to be starting with 0.5 grams of silver nitrate. So I need to go from grams of AgNO3. If you remember in stoichiometry, we always are going to have a mole ratio. So I need to convert moles of silver nitrate into moles of what I'm looking for. That's silver chromate. Okay, so that middle step is going to be our mole ratio. I'm then going to convert it into grams of Ag2CrO4, and that's going to be my theoretical yield. So all I'm going to do is that same stoichiometry, the same 3 steps that we've been doing before. So we'll take our 0.500 grams of AgNO3. We're going to convert that to moles first, so grams to moles. I'm going to add up the silver, the nitrogen, and the 3 oxygens. So if you add all of those up, the silver, the nitrogen, and 3 oxygens, that's going to have a mass of 167.87. Grams will cross out. I'm then ready for my mole ratio. So moles of AgNO3 get turned into moles of Ag2CrO4, okay? If I look at my mole ratio, this is balanced for me. AgNO2 is going to have a 2 in front of it. This will have a 1 in front of it. Moles of AgNO3 crosses out. And then finally, I need to convert back into grams so I can figure out my theoretical yield here. So to do that, I'm going to put moles of AgCrO4 on the bottom, and I'm going to add up the 2 silvers, the chromium, and the 4 oxygens. This is a very heavy compound. This is going to have a mass of 331.73 grams. Moles of silver chromate crosses out, and then I'm going to go through and solve it. So my theoretical yield is going to be 0.494 grams of Ag2CrO4. This is my theoretical yield, okay? So I found how much I should be making. If I gave someone 0.50 grams of silver nitrate, I would expect them to make exactly this much silver chromate. However, did I make as much as I should have made? No. Look at this next part of the problem. We only produced 0.455 grams. So I made less. So I need to figure out what my percent yield is. So the actual yield is what we found in the lab, 0.455 grams. The theoretical yield we found from the stoichiometry on the previous slide, 0.494 grams. So percent yield is actual over theoretical times 100. So in this case, 0.455 divided by 0.494 times 100. That will be equal to 92.1%. So what that means is you produced 92.1% of what I expected to make based on the theoretical yield that I should have made. So at this point, you should be able to calculate that theoretical yield using stoichiometry. Oh, I spelled that wrong. Oh my God. Using stoichiometry. And you should be able to compare what you actually made versus what you should have made, and that's what we call a percent yield.